So everyone, welcome back. So in this video we want to do a review of chapter 7 of class 11, basically the NCERT textbook Mathematics class 11 chapter 7, which is about permutation and combination. And I'm doing this because I was doing basically chapter 16, and in chapter 16 I found an example that was basically based on the concept of permutation and combination. And of course, permutation and combination must be there, of course, throughout all of mathematics. So it's necessary that we understand it. Now, I'm not going through the whole chapter, but the concepts and some necessary exercises and examples we will do. And that's what we will do basically basically related to chapter 7. And chances are that you've come basically here from chapter 16, which of course would be the right thing to do if you have done so. And otherwise you might have chosen to do this chapter independently, depending on your needs. Whatever the case, I welcome you to this series of videos, maybe probably 4, 5 or 6 videos, and then we will get to the rest of chapter 16. So now let's get started. Now suppose that, for example, you have a suitcase with basically a combination on it. So you have basically a combination is usually a combination of for example 4 digits on there is a log that you can change these digits. Each of these digits goes from basically 1, 0, 1, basically 2, 3, 4, for example, 5, 6, all the way up to 9. So you have 10 digits here, you have 10 digits here, 10 digits here, and 10 digits here, and then you can change these in order to get basically different 4-digit numbers. And the right 4-digit number is going to open your lock. So basically the lock can be opened if 4 specific digits are arranged in a particular sequence with, for example, the particular combination that we have here in this particular case. Of course, normally you can have repeating numbers in these locks, meaning that when you set the code, there is basically some sort of very tiny lever that you can lift up, and then you can basically adjust the code, and then from then on the lock will be opened using that code only. So for example, when you set the code, you can set it, for example, to 2, 2, 2, and 2. You can set it to 3, 3, 2, 2. You can set it to 3, 5, for example, 6, 6, or any other 4-digit code for that matter. So the code, basically the digits can be repeating. But in this particular case, in this example, we are assuming that the lock can be opened if 4 specific digits are arranged in a particular sequence with no repetition. with no repetition. No repetition. So if that's the case, and suppose that you remember that you have basically forgotten the combination, but you remember that the first digit was a 7, and then the rest of the digits you have forgotten and you can't remember that. Now, basically, the question that we want to answer here is how many sequences of 3 digits you may have to check before you can basically open the suitcase, right? Now, to answer this question, you may immediately start listing all the possible arrangements of 9 remaining digits taken 3 at a time. You may start listing all the possible arrangements of 9 remaining digits taken 3 at a time. But this method will be tedious because the number of possible sequences may be large. Here in this chapter we shall learn some basic counting techniques which will enable us to answer this question without actually listing 3-digit arrangements. And in fact, these techniques will be useful in determining the number of different ways of arranging and selecting objects without actually listing them. So, if the question is not clear, or basically if everything that I just read here is not clear, we will be doing just that during the rest of this chapter. And so, once we basically, as we go through this chapter, the subject becomes clearer and clearer until at the end of the chapter we have a clear understanding of counting and how you basically count and how you do different things when you have a large number of objects. And for example, you want to select for example, suppose you have for example 5 apples, 5 different apples, and from these 5 different apples you want to pick, for example, 3 apples or something like that. But I'm not going to go into detail right now, although it would be nice if I could. I have mostly forgotten the theory related to this chapter, so that's basically why I'm reviewing this chapter. So let's get started. We will basically go through the material bit by bit. Okay. Now probably the most important thing here is something called the fundamental principle of counting, which you need to be familiar with. So the fundamental principle of counting what that is that let's consider the following problem. So you have basically Mohan has 3 pants and 2 shirts. So Mohan basically has 3 pants and 2 shirts. So how many different pairs of a pant and a shirt can he dress up with? So the question that I want to answer is how many different pairs of pants and shirts can he dress up with? Meaning that if you have, for example, let's say that you have 3 pants and 2 shirts. So I call these, for example, P1, for example, P2 and P3 for pants 1, pants 2 and pants 3. And moreover, I have 2 shirts. That means that basically I can take them as S1, for example, and S2. Now, if that's the case, so for example, I could wear this pair of pants with this pair of pants with this shirt. So that would be, for example, P1 S1. I could basically wear this pair of pants with the second shirt, which would be basically, for example, P1 S2. I could wear, for example, the second pair of pants, or P2, with shirt 1 and shirt 2, which would be basically, for example, P2 S1 and P2 S2. I could wear the third pair of pants with the first shirt and the second shirt, which would be, for example, P3 and P3 S1 and P3 S2. And so it seems that we will get six different pairs of different pants and shirts, meaning that, and of course we have written them in such a way that basically none of these has been repeated in any way, meaning that, for example, pants 1 with shirt 1 has been written only once. Pants 1 with shirt 2 has been written only once. And of course, one more thing that's important here that you need to pay attention to is that I could write, for example, pants 1 with shirt 1 as P1, for example, S1. And in the same way, of course, pants 1 with shirt 1, when you're wearing a pair of pants with a shirt, it doesn't really matter whether you first say that I'm wearing shirt 1 with pant 1 or pant 1 with shirt 1. At the end of the day, you're wearing shirt 1 and you're wearing the pants 1. So basically, in this, the way that we are thinking about this problem, it doesn't matter whether you name the pants or the shirt. At the end of the day, that would be basically considered as the same, well, you could say combination. And so since that is the case, then basically I'm regarding basically these two as the same, choice, and so I'm just not listing this one here. So that's basically that. So that means that basically in total I have basically pants 1 with shirt 1, pants 1 with shirt 2, pants 2 with shirt 1 and 2, and pants 3 with shirt 1 and 2. And so I have basically 1, 2, 3, 4, 5, and 6 different pairs here. Okay, so now and if you pay attention to basically the number of pants that I I had basically 3 pairs of pants. I had 3 pairs of pants. And I had 2 basically shirts here. And I had two shirts here. And as you can see, if I multiply 3 by 2, I will get 6, which is basically the number of pairs that I've gotten here. So now let's see how we have solved this problem. So it says that there are basically 3 ways in which a pant can be chosen. There are 3 ways in which a pant can be chosen because there are 3 pants available. So this is basically the way that you talk about this is of course important. So you can say that there are 3 ways that a pant can be chosen. There are 3 ways that basically a pair of pants can be chosen because there are 3 pants available. Because there are 3, let me write it this way, because there are 3 pairs of pants available. So there are 3 ways that a pair of pants can be chosen because there are 3 pairs of pants available, right? And similarly a shirt can be chosen in 2 ways. And you can say that similarly a shirt can be chosen in 2 ways because there are 2 shirts available. Right? So similarly a shirt can be chosen in 2 ways because there are basically 2 shirts available. Now for every choice of a pant, there are 2 choices of a shirt. Therefore there are 3 times 2, which is equal to 6 pairs of a pant and a shirt. Now we will see that basically using a diagram, and you will understand what these sentences actually mean. So, and this sentence is also important, which is for every choice of a pant, for every choice of a pair of pants, there are 2 choices of a shirt. There are 2 choices of a shirt, right? Therefore there are 3 times 2. So here we said that for every choice of a pant, there are 2 choices of a shirt, and we have basically 3 pairs of pants. So therefore you can say that there are basically, if there is for for basically if for every choice of a pair of pants, there are two choices of a shirt. That means that for the first pant, for example, P1, there are two choices, right? For the second pair of pants, which is P2, there are again two choices. And for the third pair of pants, P3, there is again two choices, right? So that means that then you can say that in total there are three, so you have three pairs of pants here. So there are 3 times 2, which is equal to 6. There are 3 times 2, which is equal to 6 pairs of pants, basically 6 choices, meaning 6 pairs of pants and shirts. Okay, so now to understand this a little bit better, what we can do is that we can call these pants and shirts as P1, P2, P3, S1 and S2, for example, as we did before. So for example, let's name basically the 3 pants as the 3 pairs of pants as P1, P2 and P3, and the 2 shirts as S1 and S2. Then these 6 possibilities can be illustrated. Then you can say that then the possibilities can be illustrated as below. Okay, so now basically in this situation we have 3 pants and 2 shirts, right? So the 3 pants and 2 shirts, basically I can illustrate this problem very easily this way, meaning that I can say that, okay, so I have basically pants 1, I have pants 2, and I have pants 3 over here. Each of these pants can be worn can be taken with basically 2 shirts here, meaning that over here I have S1 and I have S2. Again, pants 2 can be worn with S1 and S2. Again, pants 3 can be worn with S1 and S2. So that means that I have basically these 2 choices here, these 2 choices here, and these 2 choices here. So then in total, I can say that I have 3 times 2 choices. I have basically 3 times 2, which is equal to 6 choices of different different pairs of pants and shirts. So meaning that I have 6 different possibilities, right? Or let's consider another problem. Let's consider another problem. And the next problem that we have is basically Sabnam. We call it Sabnam. Has 2 school bags. She has 2 school bags, 3 tiffin boxes. She has 3 tiffin boxes and 2 water bottles. 2 water bottles. Right? So now the question that we want to ask, the question we want to answer is in how many ways can she carry these items choosing one from each. Choosing one from each. So meaning that, for example, if I have, for example, school bag, for example, if I call it, for example, bag 1, for example, if I have bag 1 and bag 2, if I have, for example, tiffin box 1, tiffin box 2, tiffin box 3, T1, T2, T3, and if I have, for example, the water bottle 1, W1 and W2, for example, I could take, for example, B1. I could take B1 with, for example, T1, the tiffin box 1 with the water bottle 1, and that would be basically one complete set. On the other hand, for example, for example, on another day, I could take the bag 2 and tiffin box 2, for example, and the water bottle 1 again. That would still be another different combination on another day, and so on and so forth. Meaning that, for example, you have a number of pants, you have a number of shirts, you have a number of socks, you have a number of, for example, shoes, and so on and so forth. And of course, that's not the kind of thing that I usually do, because I don't have, personally, I have, for example, 1 pair of pants and number of shirts, and, for example, a number of socks that basically are quite similar. And almost every day, I do wear the same thing. The same combination, basically. But some people basically mix and match, meaning that, for example, they take, for example, pants 1 with this pair of pants with another shirt, the next day they change, and the next day they change. So that's the kind of problem that we are solving here. And so, for example, over here we have taken water bottles and, for example, tiffin boxes and school bags, but that's still the same kind of problem. So now what the way that, for example, we can solve this problem is that basically the argument that you can have, or the way that you can think about this problem, is that since you have two school bags, you can say that basically school bag can be chosen in two different ways. So you can say that a school bag can be chosen in two different ways. After a school bag is chosen, or once the school bag is chosen, then a tiffin box can be chosen in three different ways. Then a tiffin box can be chosen in three different ways. And okay, so now basically school bag can be chosen in two different ways. We already basically talked about that. And then once the school bag is chosen, then a tiffin box, for example, can be chosen in three different ways, because we have three basically tiffin boxes. And of course we are assuming that these tiffin boxes are, they are different, meaning that if you chose, for example, the first tiffin box, or if you chose the second tiffin box, you would actually recognize the difference. That's basically excuse me. That's basically the assumption that we are making. Otherwise, if your tiffin boxes were similar tiffin boxes in such a way you wouldn't that you wouldn't know the difference when you chose the different ones, then of course basically the whole situation wouldn't make any sense. But we are assuming that, for example, you have, well, exactly three different tiffin boxes, okay? And so then a tiffin box can be chosen in three different ways. Hence there are 2 times 3, which is equal to 6 pairs of school bags and tiffin boxes. And so hence there are 2 times 3, which is equal to 6 pairs of school bags, and tiffin boxes. Now for each of these pairs, a water bottle can be chosen in 2 different ways. Meaning that, now to understand this part, actually it's very important to understand this concept of combination and permutation, because it's used in all the different fields of mathematics. And the reason why that's the case is that basically permutation and combination. And for example, over here we are essentially talking about combination, for example, the concept of combination. And these are nothing but, as you can see, even as the examples show, these are basically two different ways of counting, meaning that unless you know basically the concept of permutation and combination and some other basically concepts linked to them that we will do basically later after this, you do not know how to count mathematically. In mathematics, you need to be able to count essentially all the way up to infinity. When you understand that the concept of basically, when you understand the concept of permutation, when you understand the concept of the concept of combination, the concept of, for example, there are few other concepts that will be linked into these concepts, and then when you understand them, for example, then you will have the binomial theorem, and then after the binomial theorem you will have the basically the series and infinite series and that sort of thing. Then once you put all of these concepts together, you will be able to count all the way up to infinity, and that you could do in just a few seconds, and your results would every single time be absolutely correct without making any mistakes. It's actually like magic. So that's basically how you count. That's basically how you count in mathematics. You need to understand basically combination, you need to understand permutation, and a few more concepts. Put them together, you will be able to count all the way up to infinity. Okay. Now, so here we said that a school bag can be chosen in two different ways. And once the school bag is chosen, then a tiffin box can be chosen in three different ways. So what that means is that basically you have basically one school bag here, for example, B1, and we have another school bag here, B2. And a school bag can be chosen in two different ways, right? So one way and one way, two different ways. And then let's suppose that once I choose the school bag, then I want to choose my tiffin box. So that means that I write, for example, here T1 or T2 or T3 here. So then the bag goes over here, is linked to these three choices, is linked to these three choices. And so as you can see, you have basically there are three ways of choosing a school bag with the three tiffin boxes that you have. And in the same way, you have basically again the same three tiffin boxes, T1, T2, and T3. And then you can choose the second school bag with basically the same tiffin boxes. And so that's basically why we say that there are 2 times 3 pairs of school bags and tiffin boxes. Meaning that there are 2 ways of choosing a school bag, there are 3 ways of choosing a tiffin box, and 2 times 3 is equal to 6 ways. So you have, for example, here you would get B1 T1, here you would get B1 T2, here you would get B1, for example, T3, here you would get B2, for example, T1. Here you would get B2, for example, T2, and here you would get B2, for example, T3. So 1, 2, 3, 4, 5, and 6. So as you can see, once you understand this concept properly, then you will be able to actually count using this method. And that, I mean, that's actually a very clever way of counting. Okay. It's not just about, for example, solving problems like, for example, we have, for example, 5 people or we have, for example, 10 people and you know, the typical kind of problems that you solve here in combination and permutation is that, for example, we have 15 people, and out of these 15 people we want to basically choose a committee of for example 5 people. In how many ways can we do that? For example, then you could argue that I would take, for example, if I take the persons as person 1, for example, person 2, and all the way up to, for example, person 15, then I will choose, for example, person 1 with person 2, person 3, 4, 5, 6, 5, all the way up to 5. Then I will take, for example, the next 5 people, then I will take the next 5 people, and then I will take, for example, I will switch, for example, the first person, and so on and so forth. And in that, basically, that way I will have basically, for example, n different committees of 5 people chosen out of 15 people, right? Which would be a time-consuming process, basically, to go through, right? So this is the typical problem that you basically solve in combination and permutation. But, well, of course, it's good to be able to do that. But the very basics or the very foundations of combination and permutation is just about counting. And once we get to the end of this chapter, you will hopefully be able to count properly. So then, for example, you have basically, now you have chosen your tiffin boxes, you've chosen your school bags, and then after that we have basically the water bottles. So now each of these basically combinations of bags and tiffin boxes can be chosen with basically 2 water bottles. So you have W1, for example, W2, W1, W2, W1, W2, and for example, you can connect these together. You can again connect these over here, or you can basically connect these over here, and then again you can do the same thing over here. Each of these combinations in turn can be basically taken with 2 choices of water bottles, meaning that, for example, you have W1, W2, you have again W1, W2, you have again W1 and W2, and that's basically what happens here. So again, hence there are basically all the way up to here, we said that hence there are 2 times 3, which is equal to 6 pairs of school bags and a tiffin box. Now for each of these pairs, for each pair of a bag and a tiffin box, a water bottle can be chosen in 2 different ways. So for each of these pairs, a water bottle can be chosen in two different ways. A water bottle can be chosen in two different ways. In two different ways. And hence there are 6 times 2, which is equal to 12 different ways. Hence there are basically all the way up to here we had 6 completed, basically in total 6 different ways. So 6 times 2, which is equal to 12 different ways in which different ways in which Shabnam or Sabnam, actually the name is supposed to be Shabnam, I suppose, because Sabnam, I'm not really sure if that does even exist as a name, but I have heard of the name Shabnam in it's a name in Iran. It's a Persian name or something like that. But of course, then you get the same names in India as well, of course. So, because then the language, the Hindi language is of course influenced by basically the Urdu part of the language, which is of course essentially the Persian language. So Sabnam can carry these items. Can carry these items to the school. If we name the 2 school bags as, for example, B1, B2, and the 3 tiffin boxes as T1, T2, and T3, and the 2 water bottles and W1 and W2, then these possibilities can be illustrated this way. So you have these 2 water bottles, and these 2 water bottles, basically this whole basically illustration that you can see over here. So basically, then in fact the problems of basically the problems of this type that you get of this type are solved by applying the following principle known as the fundamental principle of counting. So basically all along as we were solving this problem, we were actually applying something called the fundamental principle of counting. So the fundamental principle of counting, or simply the multiplication principle. They call it also the multiplication principle. So you have the fundamental principle of counting or the multiplication principle. So the multiplication principle, what it is that basically if an event can occur in m different ways, if an event can occur in m different ways, following which another event can occur in n different ways, following which an event can occur n different ways, then the total number of occurrences of the events in the given order is the total number of occurrence occurrence of the events in the given order is m times n. As it seems that the order is also important, but since you're multiplying, I don't see how the order can be important as far as the result is concerned, but well, okay. Okay, so now and also this basically this result, or the principle, the fundamental principle of counting, it can be can be generalized for any finite number of events, meaning that, let me create a new layer here. So it says that the above principle can be generalized for any finite number of events, for any finite number of events, any finite number of events. For example, for 3 events, the principle is as follows. For 3 events, for 3 events, the principle is as follows. So then for 3 events, I can write the principle as basically if an event can occur in m different ways, following which another event can occur in n different ways, following which a third event can occur in p different ways, then the total number of occurrences to the events in the given order is basically, then the total number of occurrences to the events in the given order is m times n times p. So basically, then you can see that if an event can occur in m different ways, if an event can occur in m different ways, following which another event can occur in n different ways, following which another event can occur in following which another event can occur in n different ways, in n different ways, following which a third event can occur in p different ways, following which a third event can occur in p different ways, then the total number of occurrences to the events in the given order is m times n times p. So, and that way you can generalize this principle to any finite number of events, basically happening one after the other, and so on and so forth. So now what I'm going to do is that I'm going to basically end this video here, and then we have a little bit more material here to cover, and we have a couple of examples. We will go through some exercises as well to see what we can do with these concepts, and so I'll see you in the next video.